I'm primarily here today to give you a quick intro to tell you what Sidekick is and to give you a few of the insights that we've learned while building Sidekick. So, to start, this is Sidekick. Sidekick is an assistant that lives within the Shopify admin, and merchants use it to get general help with their store and manage their business. In this specific example, it's actually running on Andrew's store, who's going to join us later to talk about evals. But Andrew asked Sidekick, hey, could you fetch and analyze the sales from the last 30 days and provide recommendations based off what you've learned? And Sidekick can decompose that into individual tasks, collect all the different pieces of context, and actually generate a fairly reasonable response. So how does this work internally? At its core, Sidekick is just an agent, a very simple agent. It has an LLM that is equipped with many tools. Those tools then interact with the environment. The environment in this case is the Shopify store and other Shopify APIs. The agent can sort of reason about the tool responses and then generate a response back to the merchant, or the human in this case. Now, Sidekick today doesn't actually have that many defined workflows, and I know that many agents are built with very defined workflows in mind to keep consistency. But we actually found that by strapping an LLM with very well-defined tools, that it provides the best balance of generating the best quality responses and also giving the LLM enough space to recover from some of those error and edge cases. So it gives that flexibility back to the LLM. Now, before I continue, I do want to go back in time to when we were first developing Sidekick, and I want to go back to the handful of skills or the tools that we developed. And the main criteria of picking these tools was, one, does it provide value to the merchant? And two, does it actually save them time? There's actually no point in building a tool if the merchant can accomplish that task faster in other ways. So as an example, here are the first two tools, customer segmentation and analytics. Customer segmentation, if you don't know, is a core feature at Shopify that allows you to group customers based off a set of criteria. These groups can be used for marketing campaigns, tag them with discounts, or generally get buyer insights for your customers. But this requires that merchant to learn a sort of bespoke query language to even start digging into that data. Same with analytics. Analytics at Shopify is a wealth of information. It can give you order details, it can give you sales details, it can give you trends. But again, you as a merchant have to learn this query language. And you can imagine some of the non-technical merchants may have a bit of trouble learning this and getting even to the starting line of digging into these insights. But in the advent of LLMs, this type of problem and this type of feature is so much more accessible. You can task an LLM to generate these queries, and you can have the agent run these queries and provide the insights directly. So for these two specific skills, we actually had to fine-tune a model that was able to translate a user request into the queries you see above. Sidekick would then, in the tool, validate the response from the fine-tune, run the query, and generate that response. In addition, we were considering, it's amazing Sidekick can do these complex tasks, but it would be a little funny if it couldn't do the basic tasks. So in addition to the complex tasks, we also introduced 3 of the more basic skills. The first one being navigation, which is sort of self-explanatory, but it helps merchants, especially the new ones, sort of find their way around Shopify admin, which can be a very big place. The second one is the help tool, which is your classic RAG-based tool, and it's hooked up to the Shopify Help Center, which contains all the documents that you probably need to run your business. And lastly, it's form filling. Form filling gives Sidekick the ability to generate a preview of a create or edit action for any of the resources on the merchant's store. And I want to be really clear here. Sidekick itself doesn't mutate the state of the shop. You can sort of imagine this free-form agent mutating many, many things would be a bad experience for users, especially if the users don't have any input. So all it does is it provides the UI, this preview, that the merchant is given, and the merchant has to actually sign off and commit the changes on their own. Now, for the most part, we launched this, and we had a few of those skills/tools, and we found pretty good success. A lot of merchants really enjoyed the additional help that Sidekick provided. And we would be able to sort of look at the gaps between what Sidekick can answer and what it couldn't answer. And then for the ones that it couldn't answer, we'd say, let's just build a tool for that. It'll just, you can add it to the system. You can just keep growing the list of responsibilities for Sidekick. And for the most part, that worked up until when it didn't. Then we started to notice when we had way too many tools, Sidekick, the LLM, would start to confuse the responsibilities of the different tools. It would start to misuse the instructions that we had in the system prompt across the tools, and in general, it lowered the quality of the responses. And you can imagine this problem being further exacerbated the more tools we sort of prototyped within Sidekick. So a coworker of mine describes this as a death by 1,000 instructions. You have conflicting instructions. It slows down the entire processing of the LLM because you can imagine that giant system prompt being dynamically swapped out and rebuilt. It becomes incredibly difficult to debug, especially when you have other external contributors trying to add to that one system prompt. And ultimately, it's very hard to evaluate. So you don't even know if you're moving in the right direction. So what did we do? The first major refactor we had was introducing this concept called just-in-time instructions. Just-in-time instructions removes the complexity of having all of the conditionals within your main system, your agent's main system prompt, and moving it to the tool response directly. And this provides two things. One, it keeps the core of your agent's behavior pretty static. It's just the behavior of the agent that you're trying to achieve, and it still surfaces the tool instructions when you actually need them, when the tool is actually called. We also found a side benefit that this is more cache-friendly, because if you imagine a static system prompt, and we're sort of doing an append-only version of the tool results, you can maintain a longer cache, especially with those LLM providers that provide that feature. And ultimately, because now that the instructions were in the tool results, we found teams were experimenting with different instructions being passed back to the agent, using things like beta flags, depending on the model that was used, or the different pages that the merchant might be on. So ultimately, like when we have other teams contributing, the blast radius of any one tool didn't affect the core of the agent's behavior as a whole. So, what this looks like in practice is really just moving those instructions from the system prompt into the structured tool results. And this is sort of a simplified version of our help tool, but you can see that this help tool returns a very specific citations format. And when we used to have that format and those instructions in the system prompt, Sidekick would actually misuse that citations format for other tools that weren't help-related at all. So this one simple change sort of helped us modularize this process and scale out to way more tools. And from the merchant's view, of course, they don't see the structured response, but they see the agent adhering to the instructions that are provided by those tool results. So, this worked even further, and we were able to scale out to way more tools. And for the most part, like teams would introduce one tool that sort of represented their domain, and then we started onboarding more recently some more complex features at Shopify. And those teams would require sort of a crap ton of domain-specific tools that we felt like were going to go back into the original problem we have, where the main agent has to now keep track of all the different tools across multiple domains, across many complex domains. So this is something that we're sort of exploring today, and that's just sub-agents. Sub-agents are specialized agents to handle those specific domains. But the key point here is that the only agent, the main agent that the merchant is talking to is still Sidekick. Sidekick is the only point of contact, and the merchant can't really speak to the sub-agents directly. This ensures that the tone and voice of Sidekick is consistent, and you're still delegating to a sub-agent to handle some of those domain-specific tasks. So what does this look like in practice? It should look very familiar. It's the same interface. You're calling a tool from Sidekick that hands off to a sub-agent with a set of instructions, an optional conversation ID, which we'll get back to, and any other specific pieces of context that that sub-agent might need. And that sub-agent will take those instructions, run its own internal agentic loop with its own system prompt, with its own set of domain-specific tools, and then spit out, just like the just-in-time instructions, the instructions back to Sidekick, so Sidekick can actually form the response back to the merchant. And taking a pause and taking a look at that conversation ID, why would you want to have a conversation ID? You'll find that a lot of users aren't really good at providing the full spec of the thing that they're trying to accomplish in a single turn, right? They're not providing a giant brief of all the different conditions, and they want to iterate across that with multiple turns, which means your sub-agent needs to be aware of the different turns that have happened before to make sure that it knows the context to move on to the next step. So what we do is we pass back the conversation ID from the sub-agent so that the main agent can say, hey, this person is actually continuing that thread from the sub-agent. Please add this set of instructions to your conversation history so you can continue on to the next step. But with all this in mind, this is very much early exploration for us, and we're still evaluating these responses. So if I can leave you with a few takeaways, it's to stay simple as long as you can, because the simpler your system is, it's way easier to reason about your system and scale it out, and you'll have much higher response quality scores. Don't jump to the multi-agent architecture, especially not right away, because one, you're going to be adding unnecessary complexity, and two, it's going to add a lot more latency. So only really start exploring that once you have clear evidence that you might actually need it. The second point is the quality of your tools matters way more than the quantity of your tools. I think the majority of the time that we spend on Sidekick is really on tool design. We are iterating and reevaluating our tools constantly because the core of the system or the agent is fairly static. And the last bit is stay modular. There are multiple parts to your agent. By isolating those individual parts, you can reduce the blast radius of any one change and keep your agent running without too much of an issue. So keep all this in mind while I bring up Andrew, who's going to talk about evaling this system. Thanks.
Hey everyone, and thanks Charlie for the Sidekick intro. I will give a quick mid-talk intro myself. I'm Andrew McNamara. I've been building assistants now for 15 years. In 2011, we started as a startup, and we ended up powering LG and Samsung's assistants, both on their phones and TVs. We were acquired by Microsoft in 2017, where we built the first LLM assistant in Microsoft. Originally called Sydney, then Bing Chat. When it launched in North America, it was rebranded as Copilot. And now I'm here at Shopify with Charlie and the team building out Sidekick. So I'm going to share a little bit about what I've learned over the years on how to evaluate chat systems or agents, as they're kind of difficult and more difficult than normal ML models. So what I see a lot, let's say this is a theoretical member of the Sidekick team who may or may not be called Ben. There was a lot of vibe testing of Sidekick, I would say. We tried it out, it looked good, so we shipped it. Or it vibe tested well is a phrase that I've heard quite a bit. But then what would happen, it would launch, and there'd be errors, and then theoretical, who may or may not exist, Ben, he was very sad. So what kind of framework did we build to move away from this? We use LLMs, LLM as the judges, and simulators in order to really have a lot of high trust in our systems, and it really brought Sidekick, I think, to the next level. So what we do is we have a user simulator, which is an LLM-based. It's actually, for us, it's merchant-facing, so we call it our merchant simulator. The idea of it is to replay the spirit of a conversation that happened in production to our new candidate system. And our candidate system is just one delta or one change in the system because we really just want to be testing things in isolation. And then we have an LLM judge. So after the conversation is replayed with the candidate system, the LLM judge is going to evaluate it across different criteria, and then we're going to have full trust in this, and we can ship with confidence. But I'm going to talk about how to build this LLM judge and simulator, because you can't just vibe create these things either. You need a lot of statistical rigor to actually pull this off. So we create what we call a ground truth set. So all of us are developers here. I don't know how many of us have actually read specs. I don't think I've ever read specs. I imagine a lot of you haven't, despite all the hard work that PMs put into them. So what we do is we get the PMs to create what's called a ground truth set. This is different than a golden set. I have a quick definition of a golden set here. Basically, given an input X, we expect the correct output Y. And we have like a fixed number of these, maybe 1,000 or 5,000 or something. And when we test a new model, call it F, and we run this input on our new model, we get Y hat, or Y prime, as I have here. So this golden set will check, does Y prime match our expected Y in the golden set? And this is how machine learning did testing for a very long time prior to LLMs. So what we actually want to do to create this ground truth set is sample real conversations from prod or against the prod distribution, and then we create criteria and label these as humans. And then we continuously grow this ground truth set. So what a ground truth set looks like is a conversation, a criteria, like for Sidekick, it's safety, goal fulfillment, grounding, merchant sentiment, et cetera. I think there's like five criteria. And the PMs or product experts label these. It's important that we grab both good and bad conversations in this because ultimately this ground truth set should be our specs. It should have all the corner cases, it should have the bad things marked as bad, it should have the good things marked as good, and why they're good, why they're bad as part of their criteria. So we don't just get anyone to label these, we're not getting like Amazon Turk to do this. We have like, let's say 3 product experts or 5 product experts to do this, so like our PM team. What we do is, if let's say we start with like 200 ground truth set, we have 5 PM or product expert label these, and then we calculate the correlation using something like Cohen's kappa or Kendall tau. These are statistical measures of correlation. And we try to figure out, with these 5 product experts, how much do they agree on what's good and what's bad? And then we try to get coverage of, like I said, both good and bad in this ground truth set. And we calculate this number, and this we consider the theoretical max of what our LLM judge can approve. Because the LLM judge is not going to get 100. Humans are not going to get 100. So the next step here, let's say we calculated Cohen's kappa and it was like 0.69, which is actually like about what it is on Sidekick with some of the agreement between some of our PMs. And now we're going to make a prompt to try to match what the GTX is doing. So the GTX is, again, a conversation, criteria like goal fulfillment, overall, et cetera, safety. So we've labeled these criteria on these 250 conversations. 250 isn't enough, but it's a good place to start. And we prompt an LLM. You can also train an LLM or like do whatever, but you probably want to start with prompting, and you try to get it to match the humans as close as possible. So a lot of people, when they build LLM judges, if you go back, think back to the ground truth set, they have maybe 1,000 of those, and we have Y hat or Y prime and Y, and their LLM judges, does Y prime, is it semantically similar to Y, or is it close enough to Y that we consider it correct? But there's a problem with that, which is that you are then limited to the size of your ground truth set. With your golden test set. If you go this way with a ground truth set, what you're doing is giving yourself the ability to run the judge on an infinite amount of conversations that actually happen in production. So as you do your prompting, you're going to probably start with a low correlation between your prompt and the actual ground truth set of 250. And then as you keep doing iterations and iterations, you're going to get closer and closer, and eventually maybe you get to like 0.61. And again, these are actual numbers. This is what our Sidekick judge is at right now. So it's very difficult. You know, once you get to a certain point, you're going to be 0.599, 0.60, 0.61, et cetera. So you're in a pretty good state if you're at this high, and there's going to be high trust in it. The ultimate goal here is that, I hate kind of saying like Turing test here, but it is a good way to explain it. So you want to take your 5 judges and then your LLM judge, your 5 human judges, and for every conversation, or for every test in your ground truth set, you want it to be indistinguishable whether the judge was actually randomly been selected to be in the human set or not. When you've done this, that's when you know that you've quote unquote passed the Turing test. So that's a pretty statistically rigorous way to make your judge, but there's more needed. Degradation testing is also very important. So we have different versions of Sidekick called bad kick, annoyed kick, sad kick. I'm going to do everything but fulfill your goal kick, maybe. And you can run this as the candidate system. So for bad kick, maybe it's always swearing at you or being very rude. And then if you look at your criteria on this run with the merchant simulator and then the judge, you want to target the safety score. So you're going to see your safety score drop and probably the overall score drop, and you might see your other scores drop too, but you are targeting a specific criteria. So the ground truth set itself gives us the cases that we want, like the positive, like we are matching it, and now we're like targeted trying to like get bad on certain scores, which is actually what we're expecting. So degradation testing is also very important as part of the offline process. Once you have pretty high trust in it, at this stage you can go to online metric verification. So if your system is mature enough and you have online A/B tests, you can actually look at past tests, and if you have your controller treatment, control is like what was in prod when you ran the test, and treatment was your system that you wanted to launch. If you see a delta on those past experiments with your online metric, the ultimate goal is that your LLM judge aligns with your online metric. So if you've had a past test that was a new model, and this is in your online system, and the delta between control and treatment was 12%, it went up. And then you introduce a new tool, it went up by 4%. You want your judge to be directionally aligned with this, kind of magnitudely, if that's a word, aligned, but it's not going to match exactly. But if it's looking something like this, then it's pretty good. This is a good test to do because a lot of times, or a couple times, I've seen an online flight be very green, and then the LLM judge, when we run it after, is very red. And we're like, oh, crap, our LLM judge is not working as expected despite all this testing we did. And when we actually investigated that deeper, it turned out that the LLM judge was correct and our online metric was wrong. And something was happening online. Users were like clicking. Maybe we released some bad change, but users were clicked on it, but it wasn't aligning with what we wanted in the product. And the judge was able to catch that. That's the positive testing. You can also do degradation testing with online flight. So if you wanted, and we've done this, you could launch, maybe not with bad kick, but with some of the other degradation testing, you can actually launch a worse model or flight a worse model at a low percent, like 1%, and you want to see both your online metric drop and your LLM judge drop. You got to be careful about that one. That was more a Microsoft thing than a Shopify thing, I would say. Now, at this point, you should have high confidence in your judge. But this isn't enough yet to have super high trust in this and to test systems, like candidate systems that haven't launched yet. So that's where the user simulator comes in. So I kind of introduced it a little bit, but really here, with chat conversations or agents, after you have the first turn, things can diverge with your candidate systems. You can't just replay exact conversations as they were. So you need to create a user simulator or a merchant simulator to look at a conversation that happened, get the essence of it, kind of the goals that happened in it, what the merchant was trying to do or the user was trying to do. And then you want to use that and replay against the candidate system. So that LLM is going to act like a user and have a conversation with the candidate system. And then you're going to end up with a conversation that you can then use your LLM judge on, which you've gone through all this rigorous testing, and you trust. How can you trust your LLM? How can you trust your merchant simulator or your user simulator? You can't just prompt an LLM and vibe test it and be like, yeah, this is kind of doing the thing. You want to, again, use statistical rigor to build trust in this thing. So what you can do, there's many things you can do. This is just a simple thing. Run many AA tests. So take your seed conversation, run your judge on it. If it gets a score of 3.1, let's say, simulate like 100 conversations, and then check that those simulated conversations, when you run your judge on it, that they are all very similar, and then you know that your merchant simulator is doing what you want it to do. So this is, I would say, like a pretty trustable way to build LLM judge and get away from vibe testing. And you're not vibe creating an LLM judge that says, is this the same as that? You're actually building something that you can run on infinite data. There's many, many positives to this. One positive is certainly you can use it for reinforcement learning algorithms, or DSPy I think is like very popular right now. And a lot of people are doing that on their golden set with a judge. But the problem is then they're tuning their prompt with DSPy, for example, using their golden set and an LLM judge. But if their golden set is only 500, then they're basically just overfitting on that 500. So when you have a judge that's against a ground truth set, you can run it on infinite, and your RL systems are going to work a lot better with this. So what else can you do? Create skill judges, RLHF pipelines, and RL pipelines. At the end of the talk here, I'm going to talk a little bit about some of the RL we did and something to be wary of. So I'm not going to get super deep into GRPO, which is what we were using, or reinforcement learning in general, but I do want to share some of this very interesting things that happen with the judges and just something you need to be aware of. Even if you build a high-trust judge, RL is going to learn how to exploit you. And so it's kind of interesting to do as an experiment, because then you can keep iterating on your judge. For those of you who are unfamiliar with RL or reinforcement learning. Basically, at its core, you have an environment, and you have an agent interacting in the environment, and that the environment has a state. And when the agent interacts with the environment, the state changes, and then given the state change, you have a reward function, and that both of those go back to the agent, and the agent is just keep taking actions, and it's keep getting a reward and the new state of the environment. So when you think about this for training an ML model, for a generation model, let's say you have the generation, and then you have your reward model, which is, let's say, our LLM judge. That is giving a score, basically, and then that goes into our loss function, which back propagates into the model. And then the next generation is an improved version of the model based on whether the judge or reward function said it was good or not. And the longer you run it, the more steps that it runs, the higher the performance is going to be. So when we ran this on our system, like one of our fine-tuned models that did one of the skills that Charlie talked about, we saw the accuracy go from basically 79% to like 99%. And the team was like super happy, and I'm like, this is way too good to be true. So then they started doing manual analysis, and they found some pretty interesting things. So one of the tasks was let's just say generating SEO for a product description. So the answer we're expecting or something good might be like some good SEO title. But what the model was actually doing was creating a response that says, unfortunately, I can't do that for you, as that's not something I support. It can support it, but it found out that it got the highest rewards because our judge was not good enough at evaluating this task to know that it was marking this as correct, because when you read it, it considered it correct, which was a fault in our judge. So despite all that rigor, you can still have faults in your judge, and RL will find a way to exploit them. So something to be careful about. Another one, so this was like customer segmentation the model can do. So this is a model that specifically turns natural language into a segmentation query. And the correct answer is here, customer account status equals enabled. This is like an actual field in the segmentation. But you can also have free-form tags in segmentation. So what the model was doing here, after being tuned on gRPO with our judge, it was using the free-form tags to say, just look for a customer tag that says enabled or a customer tag that says active. And then when our judge looked at this, which our judge looks like the validity of the language generated, as well as if it's semantically correct in this case, and this is a valid query and looks correct, but it's technically wrong. So we had to keep iterating on our judges and improve this. So this is definitely something to watch out for when you do create your LLM judges. So some takeaways from this conversation and chat here: create an LLM judge, but don't just don't do vibe testing, but don't vibe create a judge either. That's probably the thing. So people are like, yes, I have an LLM judge, but they vibe coded their LLM judge, or it's just is my Y, they have a fixed golden set, and it's just testing, is Y the same as, Y hat? And that's not enough to really, do the tasks and get into RL and really have high trust in it. You want to align your judges to product experts. So again, not just, you probably don't even want developers on the team to do it. You want the product leaders to be doing it. And continuously grow your ground truth set. One important thing is when you are getting your ground truth set, you don't want to get only good conversations, you want to get good and bad, and you want to mark them as the merchant, not as somebody who knows what your product supports and doesn't support. So if Sidekick says correctly, I can't do that for you, merchant sentiment, overall score should be low, so that you can find these conversations, know what product features to create next. And when you do create these products, these features, then you will see your score on the judge go up. So always think from the user, how do I grade this conversation without knowledge of what it's supported or not. And when you do create these things, expect it to do reward hacking or find loopholes, especially if you're using it in an RL system. So with that, thank you. We are hiring, and if you want to come chat with us at the booth, we are there. Thanks.